I'm Noah Omer. I'm one of the platform engineers at Cyso, and I've got a MSP and security background. And well, I like reading, so there's some books up there. Maybe you'll recognize some. And I also like grand strategy games. And Cyso is a Dutch company. It's founded and independent since 1997. And there's a bunch of logos here, but we offer public cloud, we offer professional services, so we're also a managed service provider, and we offer Kubernetes as a Kubernetes certified service provider. And our company is around 100 employees strong. And this is going to be the program for this presentation. So just a quick introduction and context in relation to why we're looking at CloudStack and what kind of the motivators are for this journey. Then we'll cover data center interconnectivity. It's going to be quite broad, touching shortly on each aspect that needs to be kept in mind when designing your multi-site CloudStack environment. After that, we'll bring it back in relation to CloudStack, so the configuration within CloudStack and the need-to-knows in that configuration. And at the end, we'll do questions and hopefully answers. So let's start with the background. We currently offer a public cloud, so this is a self-service public cloud for either individuals or other companies. And this is currently based on OpenStack, so we use OpenStack Nova, which is also a KVM-based hypervisor within its own OpenStack project. We use OVN as a SDN, so this manages our software-defined networking. It's self-service. We also love Ceph, like Vito, and we offer some microservices on top of our OpenStack platform, and it has various APIs and databases to manage the orchestration. Then on our other side, we also have our enterprise hosting, and this is a lot older of an environment, and it's based on VMware ASX. We don't have an SDN here, and this was done on purpose. And it's mostly for our managed customers that entirely rely on us for their infrastructure. And it's managed with up to the vCenter layer, so we don't use vCloud Director or any of the other abstractions on top of vCenter. And we use Pure Storage and TinTree network attached storage for this environment. And then both of these environments are present in multiple data centers, primarily in Amsterdam and in Frankfurt. And they're both multi-tenant, so there's quite a few customers on both environments, and they're both long-running. And obviously, if this was all perfect, we wouldn't be here. So quickly, I'm going to cover some of the pain points we have in our current setup. So for our public cloud, so for OpenStack, we use OVN. And our experience with OVN and our data center networking, and especially the more modern data center networking technology, such as VXLAN and other more modern technologies, has been negative. It's quite hard to integrate. The last OpenStack release is moving more in this direction, but it's quite lethargic, especially compared to a project like CloudStack. Secondly, the data model. OpenStack is more of a framework to building your own cloud. It's not a turnkey solution like CloudStack is. And this gives a lot of flexibility in some ways, but because there's kind of primary contributors behind each part of the environment, you run into some issues in flexibility. You're going to have PRs that kind of sits stuck in pending forever, and you need to do your own forks for the various components that you use within your own OpenStack environment. And finally, if you use OpenStack, you're probably familiar with this, but the upgrades are quite time intensive. They're very varied and multi-step because you have all of these separate components with their own databases, their own prerequisites, their own migration paths, upgrade paths, which costs time. It's difficult to keep it up to date. Then for our enterprise hosting, well, I think everyone's aware of this one. One pain point is RAWCOM. The other pain point is the proprietary SDN, so VMware NSX, and of course also just the proprietary nature of the orchestrator, so vCenter and the layer above it, vCloud Director. And in our current setup, it's networking capabilities, which is manual. It's not SDN driven, so it costs quite a lot of engineering work to create our customers' networks that land in that environment and to do the lifecycle management for them. And then for both, we're facing issues when it comes to scaling geographically and when it comes to the stretchability of the control plane. And within both environments, we have issues when it comes to operating different stacks within the same control plane. So you have to think about, for example, storage. Maybe some customers really need fast iSCSI storage, and other customers like the capabilities of Ceph more and the kind of cheaper storage you can get out of that. So those are different use cases and different pluses and minuses that you get out of each, but you're unable to easily combine them within either, of course, VMware or within OpenStack. So why CloudStack? Why are we looking at it? Well, hopefully we can consolidate. So we currently run two platforms. We want to make one platform, which is going to make it a lot easier to keep that one platform in terms of lifecycle management, but also in terms of releasing new capabilities on that platform. And the data model and structure. CloudStack has a beautiful data model. It's quite big. It's a giant database if you start splicing it out. But there's a lot of freedom when it comes to your network offerings, when it comes to your compute offerings, your storage offerings, even your backup offerings. You've got a lot of flexibility. You can work with tags on your hypervisor nodes. You can work with tags when it comes to the compute offerings that you make available, when it comes to the storage offerings you make available. And it just kind of self-orchestrates onto the pieces of hardware that you want it to, based on this data model that you configure. And then, of course, tenancy is self-service. So OpenStack is self-service driven, and VMware is very kind of operator driven when it comes to landing customers within it. And in OpenStack, you're able to do both. You're able to segregate certain customers in terms of domains, in terms of access to offerings, in terms of access to pretty much every part of the data model that you consume and make available to customers. And then, of course, the platform components. So it would be nice if we can consolidate our orchestration plane. In this case, this would be the CloudStack management server. We can consolidate our APIs, the CloudStack API, one API, and of course the database to keep it the state of everything, which would be the CloudStack database. So a little example of this flexibility. We currently run two zones at our office in Alkmaar in the Netherlands. One of these is a VXLAN EVPN BGP zone with virtual private VPC networking. So as a customer, you can make a VPC with, say, a public routed IP range, and it's completely segregated from the other customers. Ceph storage, an SDN, in our case, Netris, and it's meant for public consumption. And then within that same CloudStack environment, so within the same management layer, we also have a second zone within Alkmaar, and this is more kind of our targeted VMware replacement setup, where we use VLANs, so we don't have VXLAN, and the network is quite simple, it's quite flat. We use Pure Storage and Tintri for iSCSI network attached storage. We don't use an SDN, and it's for private consumption, so it's operator driven. And you can see both of them here within the CloudStack zone overview. So with that kind of context and background in mind, let's look at the kind of basics of data center interconnectivity, and I'll give an idea of the kind of choices you can make. I won't go too deep because then you can go in a lot of directions, but this gives a kind of broad overview, which I think is quite lacking when you try to research this online. So it starts, quite simple. You have a rack in a certain data center and you want to build your first zone. Well, the first thing you start with are your physical interfaces and bonds. Are you going to use SFP? Are you going to do Ethernet? So God forbid. Are you going to use bonds for those cables? Your physical networks. Are you going to run one network for both your storage and your actual customer traffic? Are you going to separate it? What about your disaster recovery backups? You have a lot of freedom in how far you segregate it, and it's very important, especially when you're thinking of, okay, I want to put another data center into use, or I want to put another rack within the same data center at the other side into use, and the switches you want to use. These all start kind of coalescing together to make these decisions. So the hardware, switches, and routers, there's a whole smorgasbord of choices here. Your OOB networking, so for example, if you're using Dell servers, you would do iDRUC. If you're dependent on what server provider you're using, this would be a different setup. Are you going to put it on a different network? Hopefully. And of course your ASNs. So in Europe that would be with RIPE. You also need to choose, are you going to have one big ASN for each data center? Are you going to separate it? There's a few choices to be made. And MTU, which it's always MTU very often. So are you going to do jumbo frames? Are you going to kind of stick to 1500 or 1550, which I'll get back to in a moment. So these are the basics. And then you kind of have a few considerations above that. So generally speaking, nowadays, your customer networking isn't going to be the same as your underlying network. So your underlying network would be your, the addresses on your actual hypervisors, the addresses on your routers, maybe your storage devices if they're separate from your hypervisors because you're not running hyperconverged. And this is kind of where the term underlay and overlay comes into play. So an underlay in networking terms is often placed on physical components, and it carries overlay traffic, and it supports overlay technologies. And overlay, there's kind of a few ways of interpreting what an overlay is. You can say a VLAN is an overlay. Generally speaking, it's viewed at the layer 3 level, so where can you route to? And overlays are generally virtualized through encapsulation, which means you need to keep MTU in mind, because if you want to support 1500 MTU traffic on your VMs, you need 1550 or maybe more on your actual physical underlay to support the encapsulation that comes on top of that traffic. And yeah, it's on top of your underlay. So your underlay is basically quite simple. It's where that overlay traffic can get to, and also, which we'll get to in a moment, what it can route over. And there's a few technologies here. So in OVN, for example, you have Genève tunnels. That's a type of overlay. And VXLAN, that's also a type of overlay. And it can be over L2, or it could also go over L3 using L4 UDP datagrams. And there are also scenarios where you could have overlays on top of overlays. God forbid, but it does happen. So, that's one part of the choices. Then obviously when it comes to actually linking your underlay within each data center, you also have considerations to be made. So one possibility is you have a private physical link. So at Cyso, for example, we have a private physical link between our office and our data centers in Amsterdam. and from Amsterdam to our data centers in Frankfurt. This is usually called dark fiber, but there's a couple of different ways of achieving the same thing. Or you have tunneled overlays. So this is where you basically just tunnel over the publicly routable internet using, something like an IPsec tunnel or a WireGuard mesh. Then you obviously arrive at your addressing scheme, because if you're doing an underlay-overlay network, you kind of want to be working at a routable level, which means the addresses you choose in each site is going to be important. You have to keep in mind the /24 limit, the /64 limit in IPv6, and then usually you would have a kind of bigger IP range above everything and then separate it into a site. And this would be called an addressing scheme. And there's a lot of ways to do it. You can do it in combination of, for example, functionality. So, okay, this is my storage network. And then further divide it into, say, /32s in IPv6 or /40s per site. And you also have to choose, okay, do I want to do IPv4? Do I want to do IPv6? Do I want to do multicast? So both. And of course, your isolation. So you're going to be routing multiple customer networks over your underlay. So how is that going to be isolated? Usually this is achieved through your overlay technology. So VXLAN and GRE are good examples, but VLAN as well, if you want to view that as an overlay. And IP, but that's quite an old and dated one by now. And then you have your control plane. And when it comes to a control plane, you basically have to view it as, okay, so I have all these routable networks on top of my overlay. Well, how does it, know where a certain IP address in that routable network is located, and how is that communicated to all the other addresses within that network, but also to other networks that need to know of that routable network. And there's a couple of different ways of doing this. So in OVN, you have your north and southbound database. And in EVPN, it's done with BGP, but there's also a different way of doing it, which is basically flooding until it learns IP addresses, and it then keeps track of that on its own. And this is only relevant for if you're doing L3 level overlay. And then, of course, your SDN. So a lot of this is configuration on your routers, on your hypervisors, and potentially on your switches, depending on how you're using them. And that can get quite cumbersome. It is possible to do, but you can also use an SDN to make it quite a bit easier. So one example is OVN, which we use in OpenStack. And another example that we've been testing in CloudStack is Netris. And you can also kind of have mix match in cases. So for example, you might have a different SDN for your edge routing to the internet than what you're using on the hypervisors. But there's a varying level of complexity there. And yeah, it can get quite confusing. I mean, there's like 30 different things to keep in mind when you're choosing each part of this stack. It needs to be interoperable. There's need-to-knows on each layer. But these are all choices that you have to make when you want to create a cloud that is supporting multiple zones for customers to land on top of. So I'm going to be giving an example, and this is kind of a continuation on a presentation I gave with one of my colleagues, Thomas, at the CloudStack Collaboration Days last year. And this was done using Netris, although I've kept the Netris specific parts out because Netris just uses open source common technologies when it comes to networking. So say you have a quite simple small scale setup. So we've got 3 servers here. You're using FRR, which is a open source routing protocol suite. It's basically just a piece of software with which you can use the various technologies that I've mentioned on each hypervisor. You've got a switch doing the same thing. and you've got two physical network servers, so to speak. And that's the setup within Netris, but you could also do it differently. Well, for your overlay traffic, so underlay, it's all able to communicate with each other. You've got your regular underlay traffic, you've got your OOB traffic, you've got your storage traffic. They've got the correct traffic type tags in CloudStack with the correct interfaces or bonds. But your overlay traffic, basically, the way we would do it is you would do it from the hypervisor host, and it needs to be routable from that point on. And ideally, routable in its own isolated environment. So this is done with VXLAN and EVPN BGP. So we have a 10.10.1.0 network, for example, on one of these hypervisor hosts. It has its own VNI. It has its own VRF, which is a virtual route forwarding table. And all of this gets communicated with EVPN to the various devices within this network, so that the moment you spin up a new VM within this isolated VPC network on one of the hypervisor hosts, it directly knows it's present there and can route to it within that network. Then you obviously have the choice to, for example, do a source NOT from one of the router servers, or maybe the entire network is already routable because it's public, so like 130 dots something address range. And it goes all the way from here, it gets advertised with EVPN BGP to your router, to the edge router, and then onto the internet. And we use Netris for this, but it's also completely fine to do with just your own automation scripts, etc., or with manual configuration. But it's quite a lot of work from what we've seen. And of course, you've got your CloudStack management server here as well. So when it comes to multi-site, I'm going to blur both of those out in a moment, but we've got two of these environments, and then we've got the internet. So to speak, you exit your data center edge, and you go onto the internet, or you have the choice of going onto a physical interconnect, so over your dark fiber. Of course, this requires configuration on your edge routers to make this happen. So you either have a tunnel between these edge routers, or you have a physical interconnect. And we have two VMs. So one limitation within CloudStack currently is that VPCs are bound to a site. And the second limitation with VXLAN and EVPN BGP is that it needs to be a routable range within each site, because otherwise, at the edge router level, it won't know which direction to go to. So you're working always with /24s when it comes to IPv4. And we've got two VPCs here. So we've got a VM on two separate VPCs. They both have different VNIs, so these are VXLAN IDs. And how we make them aware of each other, so that the customer can have a VPC in one region and a VPC in the other, and those VMs are able to connect on that private network with each other, is through VPC pairing in Netris. But VPC pairing in Netris isn't anything more than just leaking the VRF tables, so these virtual router forwarding tables, to each other. And these virtual router forwarding tables basically, in combination with EVPN, tell the traffic in the underlay level where to go to be able to reach that overlay address. So yeah, we've got a 1.4 VM on the left side, so let's say Alkmaar, and we've got a 2.5 address VM on the other side, and they're able to communicate to each other through those edge routers over that interconnect, be it physical or tunneled, using that EVPN BGP learned routes that are then leaked to each other, to each other's VRFs. So let's go back to CloudStack then. So there's some things that you need to keep in mind when you're designing your networking to work multi-site. So one part is the configuration of your physical networks on your zones. There's varying cross-zone choices. So if you have two CloudStack zones, where do you want to, for example, expose your API through? Do you want to expose it on both zones and then have a higher level API that's globally load balanced above it? That's one option. You could also just keep it separate still. And then, of course, the CloudStack database and the management servers. You're going to need CloudStack management service in both zones. But then, of course, you run into things like latency and a few other things. Within Europe, at least Western Europe, you'll probably still be fine. But when it comes to something like, for example, what US Signal has done in the US, where you have a US East and West, you kind of need a abstraction above that, which I believe is called the CloudStack region level, where you're only syncing a part of the state in that database and not all of it. So then you're syncing your domains, your customers, so their accounts, and a few other things instead of all resources between those databases. Then, of course, there's a lot of required configuration, and dependent on if you're using an SDN that's kind of integrated into CloudStack through an extension, which Netris thankfully is, or if you're doing it manually, or if you're using the virtual routers in CloudStack to do a lot of the heavy lifting, there will be some required configuration on your network hardware and, of course, in CloudStack. And all of this has a tremendous impact on the network offerings you're able to offer. So if you want to have isolated guest networks within a VPC, for example, you're going to need, in the first place, you're going to need VNIs. You probably should have VRF so that they have their own routing tables. If you want L2, that doesn't really work when you're trying to route traffic over multiple sites because you're just stuck at that L2 level. And also, there are considerations for your shared networks. And then, of course, your traffic types and interfaces. So, as I mentioned, dependent on the physical choices you've made when it comes to the interfaces on your hypervisors. You need to do the correct configuration when in the CloudStack zone for that physical network so that it goes over the correct physical interfaces to the outside world. And there's some other need to knows. So stretched interzone networking, as I mentioned in the kind of diagram, that's a bit of it's a bit limited at the moment. I think VRF leaking is quite a clean solution, and it's just the limitations of technology at the time. You can't route, /24 over two separate geographic zones. That's just not possible if you're using L3 to route over your underlay. Another thing you need to know is combining your self-service, so your dynamically allocated VNIs and your static VNIs that you, for example, need to configure for a customer because they want to extend something they have on-prem or in another environment to what you're building for them in your cloud. You need to be careful that there's no intersection and that they're not trying to use the same VNI, so VXLAN ID. And of course, the VNFs and vRouters. These are things in CloudStack that also do networking. And if you want to delegate functions fully to your physical hardware, so for example, if you want to have your load balanced IPs or your firewall rules on a piece of physical server, then you need to keep in mind that these components within CloudStack can also do that and might also automatically be doing that based on the network offering you're using. And there are a lot of network offerings that come out of the box, so to speak, when you deploy CloudStack Zone or environment in general, and you might need to tweak them or create your own. And of course, static and dynamic routing. From vRouters, it's already possible, I think a few updates ago, and it works very nicely. But if you want to do it from, say, a VNF at the moment, you're going to run into some manual work that you need to do. And of course, as mentioned, the dB latency, so that's going to be an issue if you're kind of trying to geographically spread it out more. So, I've gotten to the end, so are there any questions?
Hi, I'm Christian. This is quite a complex setup. How large a networking team would you recommend one should have to implement that?
Well, I think it heavily depends on how much you're delegating to your SDN. So Netris does take a lot of work off of our shoulders if we try to use it at a production scale in multiple data centers. But of course, a quite integrated, powerful SDN like Netris costs quite a bit of money, and there's a trade-off to be made between, do you want to do it in-house and you need to hire more engineers, or do you want to delegate some of these functions to a smart company like Netris that tries to automate parts of it for you? I would say it's hard for us at least to kind of put an estimate, but at least internally we've already looked at hiring on extra network engineers if we want to get rid of Netris.
Yeah, I had a question about the physical networking part. What are your thoughts about if you have your host, if you have it multi-homed, so multiple NICs connected to the network where you want the storage over one NIC and, for instance, the management on another NIC or something like that. Yeah, what's your take on that, and advice and maybe irritations?
Well, we use Ceph, so we kind of treat our Ceph network completely separate from the overlay network used on top of our normal CloudStack underlay. So, of course, you then run into issues with, okay, I want to replicate Ceph to another environment, and then you also actually want to have that be CloudStack aware. In our case, we currently don't do it separately, so we just do it over the same network, but if we had a production scale setup, that is something that we would want to do separately because of that, kind of zone-wide level replication that we want to look into.
Okay, thank you. I just wanted to add a thing, because the reason I asked was because we were setting it up and we were trying to set it up like you said, so separating out the storage and the front end and management network and that kind of stuff. But the only way that it's kind of possible is doing policy-based routing on the host, which I find kind of clunky, and it's potentially hazardous if it's done wrong. So yeah, I would like to see some changes there in the future. Maybe I don't know if you have the same ideas about that, but
for iSCSI, so for our kind of VMware replacement zone in CloudStack, we basically had we had the traffic type for our storage network aware. But because of how iSCSI storage is mounted in CloudStack and used, it kind of is completely separate from CloudStack awareness. It's just on the host currently. So on our hypervisor hosts, they are able to reach our Pure storage and our Tintry storage, but that isn't managed at the CloudStack level because they're local shared mount points. So we don't have experience with doing something like Ceph where you really need an address to RBD2 over a separate NIC.
Okay, so I had two questions actually for you. You were talking about IPv4 and /24s that you had geographical routing policies, of course, because that's the smallest subnet you're allowed to announce on the internet. So you have different ASNs per location?
I have to remember. Well, currently for OpenStack, we have a different ASN for our Frankfurt data center. And for CloudStack, we've only tested it currently between Amsterdam and Alkmaar, which is in the same ASN. So we haven't looked at the ASN configuration needed for when it's that far away.
Okay, because then in that case, within the same ASN, the 24 would not be a limitation. But that was something I was
Yeah,
wondering.
yeah, it would only be out when it goes out of your ASN.
Yeah, okay, correct. And then so my second question, the pure storage you mentioned, it's iSCSI. So you're using the shared mount point with OCFS on it then?
Yes, yes.
Okay.
So there's manual configuration on the, in our case, Ubuntu servers to have that mount point accessible already.
Okay, I was hoping for cluster LVM that you were using it, but it was OCFS. Okay, thanks.
Early days still.